I laugh at the way we teach math children in school. We have had trouble with it for decades, and we've tried changing for it year after year. And yet, what I find is if we had stuck with the older way and tried to improve upon it in a different fashion, that we could be far more successful. In fact, the way that I'm going to show you math is the way I've taught first graders how to do 18-digit by 18-digit multiplication. And what I will also do at the end of this presentation is to show you other methods and show you what their strengths and weaknesses are. Now, if we look at ourselves in the mirror, on the first picture we see the back of our head with our hand raised. We see in the mirror what is on the back in the picture. However, our mind perceives that we've turned around and are looking at ourselves. But if we see that, our hand has changed from right to left, or left to right, depending on how you want to look at it. If we did put our hand down, we couldn't tell the difference between those two pictures. So what happened is our mind is playing a trick on us in terms of the way we are perceiving what we see. Now, one of the other things I found is that people will notice that this is what they would think is a vertical movement. So that why is it that it turns you around from side to side but doesn't flip you upside down? Well, it turns out that if you lay on your side, it will flip you upside down. And I've given an illustration again where I put a red sleeve on you and then shown what happens is what you see in the mirror and what happens that you imagine in terms of you flipping yourself over. Okay, and again, it's symmetry that basically makes you see, makes it look like they're the same. But you have to look at it more closely in order to see that it's not like your mind is telling yourself. So you have to question and understand if you want to perceive differently. Here is a multiplication of 35 times 17. I multiply the 7 times the 35, and I get 245. I multiply 10 times the 35 and get 350. Add them together and get 595. The addition is going to be a little bit difficult because I'm not used to adding one horizontally. Part of the reason is because it's hard to line those digits up. I have to do a lot of mental effort. So that when I do on the right-hand side is the way we've conventionally taught to do it, except I've not put carry digits in it because I want to keep the problem as clean as I possibly can, make the layout simple, and make it easy to check. That's what the mental arithmetic is doing for me. Now, we have a tendency to kill creativity. So, for example, over to the left, I multiplied 15 times 17, and I've done it the way I've been taught, and I get the answer 255. However, I had discovered by using algebra that when I'm multiplying teens, I can multiply this 5 times the 7, get 35, put the 5 down in the units position like I did previously, but put the carry digit over the units digits. Now they add those. 3 plus 7 is 10, plus 5 is 15. Add 10 to that and get 25. 255 is the answer. And the algebra has shown me that this will work when I'm multiplying any two teens together. So it's not as general as the other method, but it's a way I can do multiplication faster given certain conditions. Another way I could have done this was taken the average of the two numbers, squared the average, and subtracted from it the difference that each number was from the average. And that will give me the same answer too. Again, there's algebra that tells me. Now, the second way is a more accepted way and understood, but not to be used, in your elementary classes. But the second method I gave, perfectly legitimate way of doing it, but if you do it that way, you're going to be marked down as the wrong, even though you got the right answer, and even though you showed the work. So basically what we learned, do arithmetic the way you're told, else you're going to be marked wrong. That kills creativity. So you're going to have to think a little bit more about what I said in this slide. Okay, now, basically if we were trying to teach the multiplication, what we would do is show that the 35 can be written as 30 plus 5, and the 17 can be written as 10 plus 7. That's basically number structure. And we multiply the 7 times the 5, the 7 times the 30, the 10 times the 5, and the 10 times the 30. And then add them all up. That's the distributive property. And when we're multiplying the 10 times the 30, we also know that we just count the zeros and put the zeros after it. So basically, we also have to know about the powers of 10 and the commutative property when we're doing this. So the theory may be nice, but we must consider how it's presented and used. We do multiplication as it was shown previously because it's faster and less prone to error. Now, mental arithmetic makes the problem easier. 5 times 235, I can do that in my head. But basically what I'm doing in my head is multiplying the 5 times the 5, 5 times the 3 or 30, and 5 times the 2 or 200. And then I'm moving over depending upon what power of 10 I'm using. And when I add them up, I get the same answer as do the other way, basically because the carry digits are moving over to the next place. Now, the way you're taught to do it is to multiply and make note of the carries above it. I don't do the carries because it's cleaner and it's easier to check. You end up crossing it as you do more things. But if you don't do it, if you don't show your work, you're going to lose credit. Okay, taking advantage of previous work is I can do 1, 2, 3, 4, 5, mental arithmetic, and get 6, 1, 7, 2, 5. But I'm now given the second problem, 1, 2, 3, 5, 4, 5 times 50,005. I can just copy the first multiplication. The zeros, I just put them down the zeros, and then I put the zeros to move over the number and copy down the 61725. Many kids will redo the multiplications because it takes less mental effort. But you can see that if I take into account that I know what the effect of the zeros are, and that by lining the start of the multiplication under the number, I'm going to get a much cleaner looking problem, less chance of making an error. Now, here's where you can get really cute. I'm going to multiply 124 times 124. And the way I'm going to do this initially is multiply the 4 times 124 and then 12 or 120 times 124. So 4 times 124 gives me 496. But I can multiply the 12 in two ways. 12 times the 4 is 48. Carry the 4. 12 times 2 is 24 plus the 4 is 28, and 12 times 1 is 12 plus the 2 is 14. Or 4 times 4 is 48. Carry the 4. 12 times 12 is 144, plus the 4 is 148. You're not taught to do it that way. You're basically taught to do it the way I've shown there, where you're multiplying each digit at a time and lining them up. But now that I know how to get 124 in many different ways, suppose I wanted to multiply 1 square 1245. Wouldn't I make use of the fact I already know what 124 times 124 is? Yeah, well, look at it. First I multiply 5 times 5. That gives me 25. And then I multiply 5 times 1,240, which gives me 620, or 6,200, but I have dropped the last zero to make it easier to lay the problem out. And now when I go to the 124 times the 5, I get the same answer, commutative property. So I just copy that down. And then 124 times 124, I just copy the answer from over there. And I find that the addition is easier. I only had to do 2 multiplications, the 5 times the 5 and the 5 times the 124. If I now did it the old way, look how much extra work I have to do. 4 multiplications, I have more numbers to add. So why don't I make use of the work? Well, you may say, well, you ever get a situation where you have to do that? Oh, let's take a look. I'd like to find the square root of number using the check and guess method. But what I've discovered is that I try to get it to more and more places in digits, the multiplications get more difficult. And the last multiplication you see I had to do 5 digits. The one before that was 5. The one before that was 4, and getting down. But if I want to get out to 6 or 7 digits, it's going to be a huge amount of multiplication, and it becomes tedious. But if I'm making use of my previous work, here I've taken my 2 guesses, one smaller and one bigger than the number. And now when I want to see that my answer lies between 1.4 and 1.5, when I add the 1, I just do these 2 multiplications, copy that, and copy the 196. And when I do the 2, I can copy the 196 again. And now I can see my answer lies between 1.41 and 1.42. So now I guess at the next digits. As you can see, I'm not doing much more work than I did before. A few extra digits in terms of the addition. So now a problem that I would have sort of hated to do now comes a very easy problem to do. This now really shows my understanding of the distributive property. Okay, now, one of the things I like to give to first grade students, yes, first grade students, is to have them multiply an 18-digit number by an 18-digit number. And so the reason why I picked that is because the 1, 2, 3, 4, 5, 6, which is his 6-digit number, times itself cannot be handled on a handheld calculator because it can't handle more than 8 or 10 digits. And the 1, 2, 3, 4, 5, 6 repeated 3 times and squared is going to give me more digits than the calculator. Since it's 18 digits each, that would be 36, and since there's no carry, there'd be 35 digits. So my calculator on the big computer would lose 3 digits. And so what we've shown here is if I knew what 1, 2, 3, 4, 5 was, to multiply by 1, 2, 3, 4, 5, 6, I use the same technique that I did when I was finding the square root of a number. I copy a multiplication I've done before, do one multiplication, copy the results, and multiply 6 times 6, add the numbers, and this gives me what 1, 2, 3, 4, 5, 6 squared is. Now I multiply this times this, copy the answer, multiply it by the next number, noting that that's 6 places over, so I move it over 6 places, and multiply by the next number. And if I wanted to look in terms of lining digits up, I could line it up with the top digit. Now, this answer that I get is the result of multiplying 1, 2, 3, 4, 5, 6 times the top row. Well, when I multiply by this number, it's the same thing except it's 6 places over. So I copy that answer down 6 places over, copy it down over again 6 places, and now do the work. First grade children can do this. Now, if you did it the way you were taught, you'd never get the right answer because it's almost impossible to add 18 digits in a column and get the right answer. The amount of checking you do would be incredible. So this is a problem that you wouldn't even try to do. This is what we're concerned about in math is if we know a technique and understand it, it takes a problem that would be really hard to solve and make it easy. That's how new areas of mathematics are discovered. The other thing that I emphasize is checking your work. One way is doing with division. The other way is doing some internal checking. So you would like to make sure that your answers are right along the way. So after I've multiplied 5 times 1, 2, 3, 4, 5, I multiply the answer by 2 because I know 2 times 5 is 10, and the result I should get would be the 1, 2, 3, 4, 5 at the top. The 49380, which is resulting from multiplication by 4, I'll check later. The 37035, which is the 3, I won't have a way of checking it later, so I'll just redo it again. But when I multiply by 2, after I've done the result, if I multiply that by 2, I should get the same result that I did as multiplying by 4. And now I add up my results. Notice that I have 10 digits summed up, 1 less is 9, so I should have 9 digits in my answer. And part of it, I show this, and if I multiply 9 times 9, I get 81, 2 digits, 2 times 4, I get 1 digit. I know there's a difference, has to do with the carry. So this is another technique that I can use in checking my work. Now, Let's compare this to Common Core and Sycamore Math and Khan Academy. All of these claim to teach math in more depth. They claim to explain the theory. But are they in sync with the way the mind perceives? They're using manipulatives, and I found that when I was trying to understand and learn these techniques, it took me a while to be able to understand the manipulatives. And I found I could do it just as easily using the approach I showed. But this again has to do with how the mind perceives. So we want to really look at this more than just what I do, but we want to see how children do, the students we're teaching. And can the students extend beyond what they're taught? Well, a smart one can. But the question is, it gets a little bit complicated with the different approaches. And with these other methods, there are some techniques that can make the thing a little bit simpler. But as you get to really big problems, they begin to starting to break down, and I'll show you why. This approach is the fastest of the techniques that are shown in there because it takes up less space and less writing. And so we can check that ourselves when we get the comparisons. The other techniques tend to be more prone to error, and the checking process may not be as effective. Okay. Now, what the others will sort of imply, and what I can show you here is that once you understand the distributive property, this helps you in higher math. So here I give an example where you're doing multiplication of complex numbers using the distributive property. Okay, so what's wrong with the way math is taught? It does not emphasize speed and accuracy. Students do not absorb what they taught. Their mind is fighting to learn it. Techniques taught should be alternate rather than principal approaches. So we look at the lattice technique at the left. Okay, and what we see is one of the things we have to add extra is we're writing down more numbers and we have to draw the lattice. When you get to big numbers, the lattice gets hard to draw, as I found out when I asked my granddaughter to do a 5 by 5 multiplication. I had to draw the lattice for her. Okay, and it turns out that you're adding numbers on a diagonal. And look what happened. We're putting carry digits in there. So we're putting more stuff in there to make it more difficult to check. And even if you look at the answer, we'd have to rewrite the answer to get it in a more conventional form. Copying represents a problem in terms of accuracy because we can copy incorrectly. The Arithmetic method basically is using the techniques I've done before, but basically where we've shown multiplying 5 times 23, that we had to write down 2 multiplications, add them up, rather than doing them in our head. Okay, and as you get to bigger and bigger things, you have this layout that would be more and more complicated. So the area method, they may use the box to contain it, but what they may end up doing is having more lines down. And this again makes it difficult, slows down, and leads to more errors. Both the lattice and area methods take more time, take up more space, have a complicated layout, and are more prone to errors. However, the lattice approach gives us insight to number structure, and the area method gives insight to the distributive property. They also illustrate how poor layout makes the problem more complicated and more difficult to check. So there you are. What do we do from here? We think. We make our own decisions. I've shown you a way of doing it, and I've shown you some alternate ways. And what you're going to have to do is practice to determine what is best for you. Thank you very much for listening.